So now in this video we're going to look at the 7414 integrated circuit. I have the 74HC14, the most common these days, but in any case we want a buffer. So we want a high input leading to a high output, as you can see there, or a low input leading to a low output. That gives us a buffer. You can see 1 in, 1 out, 0 in, 0 out. Now we can do that with NOT gates or inverters. So you give high to an inverter, it will output a low, but you feed that output into the input of another inverter and it'll be high again. So ultimately you get out what you get in. We can look at the circuit here. So the trim pot is set towards the positive supply. I have this wired up. You can see we got ground there. So that means that the output is high. We turn it low, and now you can see the blue LED is lit up. That's because the output is low. You can see we got high, the positive supply, on the other side of the LED there. And as always, it's better to look at the voltages on the oscilloscope. We got roll mode there, 1 second per division, 1 volt per division, 5 volt power supply. You can see we got to get above halfway because it's a Schmidt trigger, but there we go. We got above halfway and we got a high output there. Red LED lit up. Now we lower it. We got to go lower than where we last switched it because of the Schmidt trigger effect. This is the hysteresis range in the middle there, but you can see you get the high enough input, you got a high output, and a low enough input, you have a low output. And now we're going to take a closer look at how we got this wired up for those that like that. So when the output's high, it's basically connected to 5 volts, red LED lights up. When it's low, it's basically connected to ground there so that the blue LED lights up. I use this setup in a lot of videos, so we're just going to rush through that for this one here. So in any case, we have to power the integrated circuit. So positive supply, VCC, and negative supply, that's pin 14, negative supply to pin 7 down there. When it comes to each one of these inverters, the input is above the output. The inputs that we're not using, we're given a voltage, 5 volts is fine, or 0 volts. That helps stabilize things. It's best to do that. So in any case, we're not using any of those. We're using the top 2 there. So the number 1, it's over here, and that one's number 2 when it comes to these 2 inverters. So for the number 1 over there, that is the one powering our load, the output. So input on top, output there. You can see we got the 2 resistors. That is where I clipped the channel 2 oscilloscope probe. That's why it's bent like that. And then our input is up here. That input comes down to the output of the number 2 inverter. So that's the output providing a voltage, and it would provide current, but inputs don't let current in or out other than a tiny bit of trickle. So that gives us the input here. There's a little, it's just a metal jumper there, just basically like the wire on the resistor, and that is where you can see we're giving it a false signal. That is where we clipped the channel 1 probe. So it's coming to the middle of the trim pot. They're potentiometers. There's a resistive element sliding across, or there's a resistive element from one end to the other, I should say, and the wiper here slides across there, and you get a fraction of the supply voltage all the way to positive or all the way to negative or anything between, as long as you don't have to provide much if any current, which you do not because it's an input of an integrated circuit. So that's about it. I noticed that there's a lot more NOT gate options when it comes to these 7400 integrated circuits than buffers, and it took me a while to realize why, and the reason why is probably because if you're actually building a circuit with the 7400 series integrated circuits, probably not likely with practical circuits, but they're fun for learning electronics. You're probably gonna need both NOT gates and buffers, and as you can see here, we have NOT gates, and we can make a buffer too with the same integrated circuit. So we don't need 2 integrated circuits. We have 6 gates to work with here, and so a lot of times we have plenty extra that we can combine them and get something else. There are the universal gates, NAND and NOR, where if you have NAND and NOR integrated circuits, you can make literally every other logic gate and many other circuits just with the NAND or NOR. So in any case, gonna end it there. Thanks for watching. Make sure you check out one of the other videos I posted to the screen, and check out the links down below. They all help out a lot. I'll see ya in the next video.